Okay, psychiatrists wish to determine if there is a higher incidence of divorce among couples in which one of the spouses has suffered a serious head injury than among the general population. Of the 47 couples who were married, when one of the spouses had a serious head injury, 22 are now divorced. Of 53 randomly selected couples which had no head injury, 17 have divorced. So does a head injury cause people to divorce more often? Or the man's got a serious, or one of the spouses has a serious head injury. Okay, create a 95% confidence interval. Notice this one's a confidence interval, not a hypothesis test, to estimate the true difference between divorce rates in couples with head injury has occurred and the general population, where population 1 is couples with the injury and population 2 is the general population, no injury. Put in an open interval, and then what does that mean about your conclusion? All right, so let's do this. Let me add a page for us here. Okay, and let's go down and let's look at the notes. There it is. Okay, so the exam 4 notes for 2 proportions. It says use the 2 prop Z test or the 2 prop Z interval. That's what we're going to use on this one, right? Because we have a confidence interval, not a hypothesis test. This one's for a hypothesis test because it's a 2 prop Z test, but we want the 2 prop Z interval. Is that good? We'll go to 2 prop Z interval. All right, let's do it. 2 prop Z interval. So I'm going to go on our calculator and we're going to hit stat, go over to tests, go down to 2 prop Z interval. We have 2 proportions here, 2 groups, right? The couples that have a head injury and those that don't. So go down to 2 prop Z. Don't go to interval. Sorry, don't go to test. Go to interval. It's way down on B. It's way down on B. And hit enter. So this is a confidence interval, not a hypothesis test. Comes out about the same though. You got X1 and N1 and X2 and N2 and then confidence level. So what are they? Well, it said population 1 is the couples with the injury. So of the 47 couples who were married when one of the spouses had an injury, so it's 47, that's our N1. 22 are now divorced. That's X1. So, whoops. So 22 divorced out of 47. That's almost half for the people that were injured. Of the 53 randomly selected that had no injury, so that's N2, and this is X2. 17 divorced out of 53. Looks like it's a little better for the couples that did not have the head injury. Looks like a lower percentage to me. We'll see. And then the C level, the confidence level, what they ask us for, 95%. So put those numbers into your calculator. And calculate. I'm getting confidence. They want, I'm getting negative 0.0428, comma, 0.33744. Okay, but then they want me to round that, you see, to 3 places. So I got to cut it, So that'd be parenthesis negative 0.043, right? That 8 will round that to 3, comma, 0.337. So there's my confidence interval from the calculator. Now, what does this mean? According to your confidence interval, with 95% confidence, the divorce rate for couples with head injury is lower, is higher, or it's inconclusive. This is the hard part. The words are always the hard part. Is everybody with me to this point? I want you to hear this. This is the part that's going to be hard for you. Focus in with me. The rest is pretty easy. It's just hitting the buttons Here's the hard part. All right, I'm going to reason this out with you. This is the tricky part. Hear me on this now. Okay, realize that what we just did is we just subtracted two things. What am I meaning? We just took population 1 minus population 2. That's what this is. This is a difference. See right here, P1 minus P2. Population 1 minus population, and this is the injury people, the injury couples, and the no injury couples, no head injury.
Quick question.
Yes.
How do you know which, I don't know how to say it. I don't know what they're called, like the equals and not equal to. How do you
we don't do any of that.
which one
That's for a hypothesis test.
Oh, wait, I'm confused. Which one are we doing now?
I'm on number 3.
Okay, I'm on number 3. It's just I don't, wait, it's because I got disconnected.
Okay, well, so what's your question, Rosalinda?
Okay, are we doing 2 prop Z test?
No.
No, okay.
No, right here, it's interval, because this is a confidence interval, not a hypothesis test. So it's a confidence interval.
Okay,
yes, 2 prop Z interval. All right,
okay.
P1 minus P2. So we're subtracting the 2 populations.
Yes.
And like they're telling us right here. And it's the injury couples minus the no injury couples. That's what they tell me. I'm just taking the words right here. Population couples, injury.
Yeah, I got it now.
Oh, good. All right. Yeah, so I wasn't addressing you in particular, but good. I'm glad you're good there. Yeah, is everybody good here? So we're on track. So P1 minus P2. So now, guys, hear me. Guys and gals, hear me. This is it. This is the part that will confuse you. I'm doing all I can. I hope you're not dialed into something else right now. Dial in with me. This will make or break your grade. This is not easy. You need to hear from me on this. What's going to happen? Think with me logically about what it means when you subtract 2 things and you get, let's say we get a positive answer. What does that mean when you subtract 2 things and you get a positive answer? That means the first number, the first item is larger, doesn't it? Right? Like 10 minus 7 is positive 3, right? The first number has to be bigger for you to subtract 2 things and get a positive answer. Right? Are you tracking with me? If you subtract 2 things and you get a positive answer, that means the first item was larger, P1. Okay, that's case number 1. Case 1. Case 2. What if you subtract 2 things and you get a negative answer? How can you subtract 2 things and get a negative answer? What does that mean? That means the second item, well, let's just say the first item was smaller. Let's just do it that way. First item must have been smaller, right? Like 4 minus 9 is negative 5. Right? If you get a negative answer, that means the first item was smaller. If you get a positive answer, the first item was larger. You tracking with me? Everybody seeing this? Right? So it's all about what happens when you subtract 2 things. If you subtract 2 things and the answer comes out positive, then that means the first item was larger. If you subtract 2 things and the answer comes out negative, then that means the first item was smaller. So larger, smaller.
Do we have to put the number that we put in at the beginning, the first one, or not the first one, the answer for that's in the box? Do we have to put parentheses?
Yes. Yes. Parentheses, yeah. All right. So what does that mean then about our conclusion? Well, that's what the confidence interval is telling you. So the confidence interval is right here. It is negative 0.043 to positive 0.337. In other words, if I was to make a number line here, track with me, this is important, guys. Here is negative 0.043. Here's 0, and here's like positive 0.337. What's my point? We're saying the interval goes from there to there, right? We're saying the interval goes from negative 0.043 to positive 0.337. So my question is, we're saying we are 95% confident that the real difference between these numbers is somewhere in that interval. That's what we're saying with this confidence. Let me write that out. We are 95% confident that P1 minus P2 equals an answer between negative 0.043 and positive 0.337. That's what we're saying there. We are 95% confident. This is a 95% confidence interval, and that's our interval. We're saying that we're 95% confident that the answer to the subtraction, that if you subtract P1 minus P2, if you subtract them, your answer will be between negative 0.43 and positive 0.337, which means it could be anywhere in here, right? So what does that mean? The answer could be negative or it could be positive, right? Because in that interval, there's negative numbers and there's positive numbers. You see it? So the answer could be positive or negative, couldn't it? The answer could be positive or negative. It's kind of weird, I wrote a symbol there. Positive or negative. So what does that mean? Well, right up here, we just reasoned that if the answer is positive, the first number is bigger. If the answer is negative, the first number is smaller. So first number could be bigger, positive answer, or the first number could be smaller, which is what, when you get a negative answer, right? We don't know which. This is inconclusive. Inconclusive. This is inconclusive. So our answer, come back up here, inconclusive. There we go. Inconclusive. That makes sense. I know that last part is not easy. I know that's the hard part for people.
So if the first number that we got at the beginning is negative, we do it's inconclusive?
No, it's not that simple, Rosalinda.
Oh, that's what I understood.
Right, but it's a little more complex than that, right? Does everybody see what I'm saying? You've got to draw that number line. You've got to draw that number line. So you got to take your confidence interval. It's not just because the first number is negative. It's because the first number is negative and the second number is positive. It's because of both of those facts. It's because of both of those facts. Why?
So if they were,
because that means we're going from negative territory to positive territory. So that means the answer could be negative or positive, which is what throws it into confusion. That's why it's inconclusive, because it could be negative or it could be positive. If both of these were negative, so let me give you some other instances. How about that? If they're both negative, if the confidence interval are both negative, like you have negative number, then what does that mean? Well, here's 0. That means you're going from negative number to negative. That means you're confident that your number is what? Negative. It's in negative territory. So your answer must be negative. Do you see that? Answer must be negative. So if you've got 2 negative numbers in your confidence interval, then your answer must be in negative territory. And so if the answer is negative, so remember, this is all about P1 minus P2. If you're getting a negative answer, what does that mean? How do you subtract 2 things and get a negative answer? The first is smaller. That would mean logically that the first number is smaller. So if you got 2 negative numbers in your confidence interval, then that means for sure your answer is somewhere between those 2 negative numbers. It must be a negative answer. And that means your difference is negative, which means the first number must be smaller. So we would conclude in that case that the first P1 is smaller. And then there's a third case. Let me add another one. So that would be if the confidence interval comes out positive number, sorry, I'm scribbling, positive number to positive number. What does that mean? Well, here's 0, positive number to positive number. That means it's right in here. That means your answer must be positive because it's between 2 positive numbers. So if you take P1 minus P2 and you're getting a positive answer, what does that mean logically? The first P1 is larger, bigger, right? That's what that means. The only way you can subtract 2 things and get a positive answer is if the first number was bigger. So there's our 3 cases. It's all about if does the confidence interval come out both positive? Does the confidence interval come out both negative? Or does the confidence interval come out 1 negative, 1 positive? 1 negative, 1 positive. That's the story. Does everybody see that? The confidence interval comes out 1 negative, 1 positive. Then the answer could be positive or negative, right? It could be either way. So it's inconclusive, right? Like I showed here, that it could be between negative and positive. It could be this negative region, or we're 95% sure that the answer is somewhere between a negative and a positive. So it could be negative or positive. So that's inconclusive. Whereas if your interval both are negative, then you're 95% sure the real answer is between those two. It must be negative. How do you subtract 2 things and get negative? The first number must be smaller. And then third case, both positive, then the answer, you're 95% sure the answer's between 2 positive numbers, it's positive. How do you subtract 2 things and get positive? The first number must be larger. So those are the 3 cases. I put some of that on your notes. Let me show you on the exam notes to try to be helpful.
Mr. Heron.
Where is it? Right there, number 4. Do you see it at the bottom? Let me take a picture and then blow it up for you. All right, there it is. All right, number 4, it's exam 4 notes. See it right here? So meaning of a confidence interval for mu1 minus mu2 or p1 minus p2, same thing. Both negative, all negative, 0's not included, implies confidence that mu1 is lower, the first number is lower. If you get all positive, 0's not included, implies confidence that the first number is bigger. That's what I'm saying, right? If you have a positive, if you subtract two things that get positive, the first number is bigger. Subtract two things that get negative, the first number is smaller. And then finally, some negative, some positive, 0 is included, implies that it might be 0. So they might be equal. So we have no confidence. We have no confidence that they're different. They might be the same. It's inconclusive, in other words. So there we go. So let that help you. Let that guide you on this question.